Okay, let's talk about ship's body coefficients. Ship's body coefficients, well, the coefficient we are identify them by capital C and a subletter. All of the coefficients are relations and they are with no units. So just you have to check what is in the numerator and what is in denominator. The first one we're going to talk about is block coefficient, or CB. Well, it's block CB. What is the CB or block coefficient? If I'm going to draw here, if that's be our vessel, I try to draw it as a 3D. This is the water line. And this is the underline and underwater area. If we cut the top side, what we have water plan area. This is AW, water plan area. And whatever is remain under the water. So if you surrounded this one or put this one in a cube, this is, I'm going to use a cube here. Okay. So as a somehow exactly whatever was underwater area is sitting in the cube. This means length of the cube will be length between perpendicular, LBP. Beam of the cube will be maximum beam of the vessel, that's a small b. And height of the cube will be draft of the vessel, not total height of the vessel, draft, because we cut from the waterline area. So CB will be what is the value ratio of volume of the vessel over this cube, which vessel is going to surround it on that one. So volume of the vessel was volume of displacement over L times B times D. So as you have noticed, the volume is cubic meter and this one is 3 meters will be cubic meter. There is no unit in that one. And also remember, all of the coefficients are less than 1. Next coefficient is water plan area coefficient, or CW. So what is CW? If you cut the vessel, the same vessel we had, as you see when we cut it from the water line area, we have the area which is AW, water line area. If just I draw water line area here, this is your waterline area. If you are going to surround the waterline area, just put it in the rectangular, which length of the rectangular, length of the vessel, and beam of rectangular, beam of your vessel. So CW is the ratio of water plan area over the bigger rectangular, which is sitting around the water plan area. So it is AW over L times B. Again, water area is cubic meter, L and times B will be cubic meter, and there will be no unit. Next one is CM. So M is standing for midship cross section. The same vessel, I'm going to draw it again here. If this be our vessel, okay, so, and this is the waterline area. Okay, now if we're going to cut the vessel from the midship, from the mid of the vessel, what we have here, just I'm going to draw that one here. We'll have this face. This is total cross section of the vessel. And here, this was waterline area. Now, they change the color in here. Okay, so if you bring a rectangular, which could be sit around the midship cross section under the water area. This area is cross section or CM. This is AM, sorry, area of the midship, and this one is beam of the vessel, and this one is draft. So CM will be, or midship coefficient will be AM, area of the midship, over D times B. Again, this is cubic meter, this is cubic meter, and no unit. Again, just remember, all the time you are going to use smaller area or volume in numerator and the larger one in denominator. So there is no unit, and all the time your coefficient will be less than 1. We have another block coefficient here, which is prismatic coefficient. So while prismatic is CP. So what is CP? In the block coefficient, we're talking about putting the whole volume of the underwater volume of the vessel in the box. Now, in place of putting that in the box, we are going to put it in the prism. So, but what is that prism? Area of the prism is our midship cross section, this AM. I'm going to redraw this AM here. Okay, this is, sorry. Now, if you're going to change this one to a prism, okay, so this is a prism. As you can see, whole the length of the prism, the cross section, is same as AM. So my drawing is not accurate, but this is AM, AM, and AM. Now, if you put your underwater area of your vessel, underwater value of your vessel in here, I try to draw it as best as I can. Okay. So a volume of your vessel, which is Cp will be ratio of volume of the vessel, which is volume of displacement, over that will be the volume of the prism will be Am times length of the vessel. This is length of the vessel, so will be Am times length of the vessel. Okay, so now just let's take this formula as a formula 1 and this formula is formula 2. In both of them we have volume of displacement. If we mix these two together, finally you will find you can calculate the ratio between Cp, Cb, and formula 3. With these three formula, if you combine them, you can see Cp or prismatic coefficient will be equal to Cb or block coefficient over Cm, or we can calculate Cb is equal to Cp times Cm. So if we have two of this coefficient, we can calculate the third one. So we will review the coefficient more also in the chart tables, in the hydrostatic data table for vessels. There are some practice in your booklet. You can try to practice with the coefficient in your booklet.